Hello everyone, welcome to my class. So today we will discuss about the organic chemistry for O level and IGCSE. So for O level and IGCSE, organic chemistry is all about hydrocarbon and hydrocarbon derivatives. Now, what is hydrocarbon? Please remember one thing. In organic chemistry is actually the study of organic compounds. Now, what is this organic compounds? Organic compounds are actually basically two types. First one will be hydrocarbons and second one will be hydrocarbon derivatives. Now, hydrocarbon is basically any compound that is made out of only carbon and hydrogen and nothing else. So these are made out of only carbon and hydrogen and nothing else. But in here, hydrocarbon derivatives, they have actually carbon, they have hydrogen, and they have another element. Now that element can be oxygen, that element can be nitrogen, that element can be chlorine, no problem with that. But hydrocarbon only has carbon and hydrogen and nothing else. So this is a very important question. What is actually hydrocarbon? You will actually mention that organic compounds that are made out of only carbon and hydrogen. So the definition will be organic compounds that are made out of only carbon and hydrogen. Now, there are three types of hydrocarbon in your syllabus for O-level syllabus specifically, not for other syllabuses. So, first one will be alkane, second one will be alkene, and third one will be alkyne. Please remember one thing, alkyne is actually not part of O-level syllabus, but alkane and alkene is. Now, let's go to the hydrocarbon derivatives, the thing that has carbon, hydrogen, and another thing. The first one will be alcohol. Alcohol has carbon, hydrogen, and an oxygen. Second one is carboxylic acid. This one also has carbon, hydrogen, and oxygen. And third one is ester. Ester also has carbon, hydrogen, and oxygen. Now, there are some other things that are not part of O-level syllabus, but I will actually discuss those anyway. For example, amines or amines. Depends on which part of the world you actually reside. The pronunciation will be different. So amine is actually carbon, hydrogen, and nitrogen. Okay, next one is nitrile or cyanide. Same thing, carbon, hydrogen, and nitrogen. So hydrocarbon, first of all, made out of only carbon and hydrogen. Hydrocarbon derivatives, carbon, hydrogen, and another element. It can be oxygen, it can be nitrogen, it can be chlorine, many other things. Now let's move to the first part. What is homologous series? When you hear the word alcohol, the first thing that comes to your mind may be not something good, or you may think out of as hand sanitizers, but alcohol is actually a group of compound. It has like 20,000 something like compounds. For example, the body in your body, there is cholesterol. Now, this cholesterol, can you see that it ends with an ol? That means it is actually part of alcohol group. Also, you actually smell menthol once in your life. This one also ends with ol. That means this one is also an alcohol, but they do not actually behave as alcohol. Also, another thing, there is glycerin. The commercial name is glycerin, but it is actually glycerol. So as the name suggests, you can actually they say that ends with an all, so obviously it's an alcohol. So cholesterol, menthol, glycerol, they are actually part of the same group. These type of group are actually called homologous series. So they are basically series of organic compounds that has same general formula, same functional group, and there is a trend in physical properties, and similar chemical characteristics. Not same, but similar chemical characteristics. Okay. So these were the four properties of a homologous series. Now let's see how they actually behave for some of the homologous series. In your syllabus, as I told you already, there is only two from here and three from here. There are total five homologous series. First one will be alkane, then alkene, then alcohol, then carboxylic acid, and finally ester. Alcohol, first of all, alkane. The general formula of alkane will be CnH2n plus 2. This one may sounds weird, but I will actually discuss that later. Second one will be the functional group. Now you may think, what is functional group? This thing or that thing. Functional groups are actually a group of atom that actually control the chemical properties and physical properties of a group. Alkane doesn't have any functional group, so nil. There is no functional group in here. Alkene has a general formula of CnH2n. That means whatever the number of carbon will be, hydrogen number will be doubled. Alkene does have a functional group, that is C double bond C. That means a double bond between two carbon atoms. It could be any two, not all the carbon atoms. Next one, alcohol. It will be CnH2n plus 1. So whatever the carbon number is, hydrogen number will be doubled, and then you have to add an 1. Then you will add the OH part. This OH is actually the functional group. Whenever something has this OH, you absolutely think that this is actually alcohol. So also this OH actually work as an active site for the reactions. That's why all the alcohols actually behave similarly during the chemical reactions. Not same, but similarly. They may give same chemical reaction, but in different temperature. That's why it is called similar, not same. Okay. Next one, carboxylic acid. This one will be same, CnH2n plus 1, similar, but COOH. Now this COOH is actually called carboxyl radical. This is actually the functional group of carboxylic acid. This one is known as carboxyl, and this one is known as hydroxyl. Okay, can you see that I actually gave something in here, a line? This is actually a blank bond. Why did I give this blank bond? Very easy. For example, suppose this is methane. Methane formed four covalent bonds with four hydrogen atoms. Now if you remove one hydrogen atom, what will be left in here? Answer is a blank bond. So when I will write this thing, it will be written as like this, CH3, then a blank bond. That means here one atom was removed. So similar in here, one atom was removed, or it will be added with something else. Whenever there will be a blank bond, these things will be called a radical. Please remember this. So this is actually carboxyl radical, and this one is hydroxyl radical. Now a radical is very different from the ions. OH bond and OH minus, these are totally different things. This one is actually a radical. That means it has a blank bond, and this one is actually an ion. Remember that. There are very few confusing questions where they actually tell you that alcohol has an hydroxyl uh, ion. It is actually wrong. Hydroxyl radical, not hydroxyl ion. Let's move to the next one. So ester will be CnH2n plus 1, or we can actually say that something like this: R C double O R prime. This actually R means alkyl radical. This one also means alkyl radical. We are coming to alkyl radical a few moments later. Now, the functional group. The functional group is actually this one, bond C double O R. Okay, as I told you already, the R is actually the alkyl group, and you know what this bond means. Now, since I told you that I will discuss about the R part, I'm coming to that. But first, I have to discuss about the functional groups. So they are actually group of atoms that controls physical and chemical properties of a group of compounds or homologous series. I gave the examples previously. Let's move to our first homologous series. Our first homologous series will be alkane. So alkanes are obviously hydrocarbon, and you already know they do not have any functional groups. Also, alkanes are called saturated hydrocarbon. Alkanes are saturated hydrocarbons. Now, what is saturated actually? Saturated means all the carbons are actually added with a single covalent bond. That means if the chain is like this, C, 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 all the carbon has single bonds between them. Whenever they have all the carbons have single bond between them, they are considered as saturated hydrocarbons. So alkanes are saturated hydrocarbons with a general formula. CnH2n plus 2. Now let's see some alkanes. Our first alkane will be methane. Now please remember this, UPAC, IUPAC, International Union of Pure and Applied Chemistry, they actually follow Greek and Latin both numerical system. So in some cases they will actually uh, use Greek numerical system, and in some cases they will use the Latin one. So whenever this word, the word is called metha or meth. In some people actually say meth, but it is actually metha. So meth is actually means one. Eth, this one is actually means two. Prop, this one is actually means three. Buta, this one is actually means four. Penta means five. Hexa means six. I think you heard the word hexa because so if you are a football fan, whenever you hear the mission hexa or something like that. Next one will be hepta, means 7. Next one is octa. You may hear that octopus has 8 legs, so octa is actually means number 8. Next one is nona, number 9. Then deca, number 10. So from this numerical system, we can actually predict the name of the alkane. For example, name will be, we'll just add n after the name. So metha will have methane, etha will have ethane. Just add ane after the name. This one will be propane. This one will be butane. Then pentane, hexane, heptane, octane, nonane, and finally decane. Now let's start writing their formula, mainly molecular formula. We'll write the molecular formula later. For now, just write down the condensed structural formula. Now, what is condensed structural formula? You'll see that later. Condensed structural formula. You already know that their general formula is CnH2n plus 2. So whatever the carbon number will be, hydrogen number will be double, then you have to add 2 with it. So if carbon number is 1, so hydrogen number will be double of that, and with the 2 will be added, so it will be CH4. So our first formula will be methane CH4. So ethane will be obviously first of all C2. Hydrogen will be first double of that, then added 2, so it will be C2H6, then C3H8, then C4H10, then C5H12, C6H14, C7H16, then C8H18, C9H20, and finally decane. Whatever the carbon number, hydrogen number will be double plus 2, so 22. So we'll just learn the first 10 name and their condensed structural formula. Not structural formula, this is actually molecular formula, you could say. So let's just write molecular formula, because it is actually showing exact number of carbon and hydrogen in the formula. Molecular formula. So these were the molecular formula of first 10 alkanes. Now let's try writing their structural formula. Structural formula is methane. There is no change, but structural formula of ethane will be quite different. First, you have to give 2 carbons, and both of them will be added with a single bond, single covalent bond specifically. Now, we know that carbon is actually part of group number 4. That means carbon can actually make 4 covalent bonds. Out of those 4 covalent bonds, carbon just now made 1. So 3 of the covalent bonds are actually left. So we can easily assume that it will make another 3 covalent bonds. This one will also make another 3 covalent bonds. So here, add the 3 hydrogen in here. Now let's write it as, this one is CH3. So write CH3, a single bond. Then this one is also CH3, CH3 bond CH3. This CH3 bond CH3 thing is actually called the structural formula. Here in shortcut, you are actually showing the exact number of carbon, hydrogen, and some specific bonds that are needed. Next one, propane. So 3 covalent bonds, 3 carbon, and all of them are attached with single bond. Now How many bonds are left for this carbon? Answer is 3. So give 3 hydrogen in here. This carbon already made one covalent bond in here, another covalent bond in here. That means it has 2 more covalent bonds left. Give 2 hydrogen for this one, and this one already made one, so give 3 hydrogen for here. So we just have the structural formula of propane. Let's move to butane. Butane is actually 4 carbon atoms, C, 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 C. Add a single bond between them. So this one will be 3. Can you predict this one? Can you predict how many hydrogen will be in here? Answer is 2, because it already made 2 covalent bonds. CH2, CH2, and CH3. So C5H12, I think you can actually predict it. C, 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 C. Add them with a single bond. Give 3 hydrogen in here, 2 hydrogen in here, 2 hydrogen in here, 2 hydrogen, 2 hydrogen. Now we have the structural formula of pentane. Now let's move to a different type of formula, that is called displayed formula. You can see that in the structural formula I did not show every single bonds. I only show the bonds I needed to be shown. Now in displayed formula you have to show exact number of atoms and exact number of bonds in a single compound. For example, in methane, the displayed formula will be like this. So carbon made 4 covalent bonds, and with this 4 covalent bond it actually grabbed 4 hydrogens. For ethane it will be like this: 3 carbons, and each of them actually grabbed 3 hydrogen with 3 covalent bonds. Now what will be the displayed formula of propane? First of all, write this one, CH3. Then this one is added with a CH2. That means C, 1 hydrogen, 1 hydrogen. This one then 3 hydrogen, 1, 2, 3. Now we have the displayed formula of propane. I'll show the butane one now. 4 carbons like this, 1, 2, 3, 4. Single bond between them. Now 1, 2, 3. Single hydrogen, single hydrogen, single hydrogen. So this was our displayed formula of butane. So that's all for today. This was the first actual public video in my channel, because I do not post public videos. I actually post private videos for my own students that actually I teach in private. So let me know if you actually liked it, and if you think it actually helped you, then give a like and subscribe to my channel. Okay, peace.